Hey everyone! Today I'm going to change my character's outfit. No t-shirts, jeans, or jackets needed. Nope, no modern clothes at all. I want to make this challenging. As a reference, I'll use a complex historical costume where every single detail is a work of art in itself. Today, you'll see just how accurately you can transfer patterns, shapes, colors, and textures of an outfit using the ACE++ extensions and the Redux style preservation model. To make the task as tough as possible, I'll be transferring clothes from a person with realistic body proportions onto a 3D character with distorted, elongated proportions. As the song goes, the main thing is that the outfit fits. As an example, I chose Louis XIV's outfit from the 2000 film The King Dances. Historical fact: the young king performed in a ballet where he portrayed the sun.
Puissance.
Сила.
Plaisir.
Удовольствие.
Lumière.
Свет.
After that, he was forever nicknamed the Sun King. Here's my workflow, which you can download via the link in the description, or just follow along here. I'll explain all the nuances in detail. If, after loading this workflow into your ComfyUI environment, some nodes turn red, go to the manager and install the missing nodes. But first, run an update for everything. After all the changes, restart ComfyUI. Refresh the page, perfect. So, this node provides links to all the resources used in this workflow. Also, info about each model used is written in the node's properties. Now, if you're missing a model, a message will pop up when loading the workflow with an option to download it right away. But you choose the download folder yourself. If the model exists but is named differently, just ignore the message. That's it for the intro. Now let's get to work. The process is divided into stages based on the number of groups. Since we're starting with the first group, we'll keep only that one active and deactivate the rest. Load the image of your character that needs the outfit change here. In the mask editor, draw the mask, but always consider how wide or voluminous the future clothing will be. For example, I have very wide sleeves, so I account for that in the mask. Otherwise, the program will try to squeeze wide sleeves from the reference into a narrow mask. Load the reference image here. A mask can be present here or not, depending on which mask creation method we choose. Manual, like here. Or automatic, using the layer mask, Segformer B2 Clothes Ultra extension. Here's a switch node to select the mask option. The automatic clothing segmentation model works great with modern clothes or outfits where details are obvious. For example, I selected the upper part of the clothing, and the program handled it perfectly. The extension responsible for this is called Segformer B2 Clothes. Download all files from the developer's page and place them in the models folder. Segformer B2 Clothes. In my case, the outfit is very complex, and the program didn't handle it very well. It grabbed a bit of hair, didn't show the full beauty of the sleeves with gold applique, and part of the armor didn't make it into the selection. The automatic option didn't work. I'll do it manually. Switching to the second option, open the mask editor, and here's an important point. When masking the reference image specifically, it's crucial to select as precisely as possible without going over the edges. It's better to fall a bit short. The program will understand and fill in correctly. But if you go over and grab background, part of that background will end up on the new character. The program will treat the background as part of the clothing trim. I masked it carefully, and everything turned out great. There are also two identical nodes. Image scale by aspect ratio phi 2. They're used here to resize images. In this one, the size is left as is. Here, I set it to 1024 on the shorter side. You configure this yourself as needed. I also assigned variables for the main image and its mask, and the reference ones to call them later in another block. Next comes the equally exciting part, creating a detailed description of this clothing piece. For high-quality copying of all complex clothing details, you need to not only show the program what the outfit looks like, but also describe all its nuances in detail. Here, you can also choose your preferred option: automatic prompt generation using the Florence 2 language model, or writing the prompt manually. We need to describe this image, which consists of right and left parts. So the prompt will have 3 parts. The first describes, "This is a pair of images." The left part highlights. This part comes from here. The second part is the main one, detailed description of the clothing piece. As I said, it's done either automatically or manually. And the third part, a very concise character description. I wrote that it's a young man in the Tim Burton style with elongated arms and legs, but that's optional. You can just write, "young man." This node combines scattered prompt pieces into one. But this node has 2 parts, the beginning and sort of a variable, which comes from here. This variable replaces the word prompt with text. This way, a compiled prompt arrives here. And in the 2 bottom fields, old text is replaced with new, either from Florence or from the manually written prompt, depending on the selected option. That's all for this. Moving to the next group. In this node group, we simply combine 2 images into one and get the mask for the clothing part that needs changing. Here, we call the variables assigned in the first node group. The fourth node group is image generation. The model loader uses flux fill. Attention, this is critically important. No other flux model, just flux fill. This is an in-painting model that knows how to fill masked areas. You can download it from the developers page, Black Forest Labs. Next, the LoRA related to the ACE++ extension. Download from the developers page. Links to all models are in the video description. Text encoder loader. VE model loader. The next node group relates to the Redux model. This model excels at transferring style. Here, you can set its influence strength. Next is the in-paint model conditioning node. It receives our combined positive prompt, negative prompt, combined image, and mask. K-sampler. Result quality directly depends on the number of steps. For example, with few steps, the clothes might not fit well, but at 25 to 35, perfect. Experiment. The generation result is a combined image. Now we need to keep only the useful part. For this, several simple nodes are used, one of which is mathematical. It subtracts the left part from the total width. And this node handles cropping. Let's take a closer look at the result. Notice how accurately complex details are transferred, like the sun emblem with rays on the cuirass. Even the scaly armor pattern is rendered very sharply. Or the little suns on the knees. And the shoes, they're just perfection. This workflow is mostly tuned for outfit changes, but you can also use it to swap any non-clothing item. Just mask it manually and write the right prompt. So, I think the task is fully accomplished and the tough goal achieved. Maestro lights! If the video was helpful, give it a like and subscribe to the channel.